Alright, Assalamualaikum and good day to those who are watching this video. So in this video, I will be guiding you on how to solve questions from your Zero to Hero Semester 2, Session 2022-2023 for Chapter 7, Haloalkanes. So let's proceed to question number 1A. Classify the following compounds as either primary, secondary, or tertiary haloalkane and give their IUPAC name. So we have first structure here. What you need to do is identify the functional group halogen first. So in this case, your halogen is fluoro. So your carbon number 1 is the carbon holding the functional group, followed by carbon number 2 and then carbon number 3 over here. So you have now two substituents, fluoro at carbon number 1 and methyl at carbon number 2. So this will be called 1-fluoro-2-methyl propane. As to the class of this haloalkane, the carbon holding the functional group fluoro will be labeled as alpha carbon, and this alpha carbon is only neighboring with one more carbon atom. So this is primary haloalkane. Proceed to question number 2. Again, identify your functional group. In this case, it's iodo. So the carbon holding the iodo should be labeled as carbon number 1. And your parent is now cyclopentane. So cyclopentane has substituent iodo at carbon number 1 and also methyl at carbon number 1. So because iodo starts with an I while methyl starts with an M, iodo should be at the front according to its alphabet. Therefore, this is called 1-iodo, 1-methyl cyclopentane. As the class of this haloalkane, the carbon holding the iodo is labeled as alpha. So this alpha carbon is neighboring with another 3 carbon atoms. One here, and also another one here. So that's why this is class tertiary haloalkane. Proceed to structure 3. Again, the functional group here is chloro. So this is labeled as carbon number 1 followed by carbon number 2. According to IUPAC, you need to find the longest carbon chain. So your number 3 should be on the left followed by number 4 and then number 5. So you have 5 carbon chain as your parent with chloro attached to carbon number 1, methyl at carbon number 2 and another methyl at carbon number 3. Therefore, your structure is called 1-chloro-2,3-dimethyl-pentene. As to the class of this haloalkane, the carbon holding the chloro is labeled as alpha. So this alpha carbon has only one neighboring carbon atom. So that's why this is primary haloalkane. As for the name, each name and correct classification gives you 1 mark each. So this is 2 marks, another 2, and another 2 marks. So total question 1A is 6 marks. Proceed to question number 1B. Draw the structural formula of the following compound. So first, 3-bromo-3-methyl-hexane. So your parent is hexane, therefore with 6 carbon atoms. Carbon number 3 has Br attached, while carbon number 2 has methyl attached. Proceed to question number 2, sec-butyl bromide. So sec-butyl is actually the name for a substituent that has 4 carbon atoms and it has a secondary carbon attached to the parent. So this is the secondary carbon, hence the name sec-butyl bromide. But because the parent is called bromide, this is actually common name. So the structure should be sec-butyl with Br attached to the secondary carbon. Question number 3. 2-iodoethyl cyclopentane. So your parent is cyclopentane and it has a substituent of ethyl iodo, and the iodo is attached of carbon number 2 in the ethyl. So this will be your 2-iodoethyl cyclopentane. So in terms of mark, each of the correct structure gets you 1 mark each. So remember, for drawing structural formula, it doesn't matter whether you draw condensed, skeletal, or even expanded, because these 3 falls under the name structural formula. But I really encourage you to do either condensed or skeletal because they both save a lot of time. I do not encourage you to do expanded at all. Okay. Let's proceed to question number 2a. Draw the structural formula of AA to HH in the following equations. So question number 1, you need to draw what is AA. So in this case, this is the type of reaction for haloalkane. Br is going to be substituted with OH, which is nucleophilic substitution. So your product of AA should be CH3CH2OH. Okay, question number 2. Again, this is going to be nucleophilic substitution, but Cl is going to be substituted with all of these CH3COO minus. But be very careful that your substitution is starting from the O minus. Okay, so instead of Cl, the place will be replaced with OOCCH3, which is, this is an ester structure. So this is your structure BB. Let's proceed to question number 3. First, you have Br with Mg dry ether. So this is preparation of Grignard reagent. So you have MgBr, which is your structure CC. After that, the Grignard reagent reacts with methanol. So this will produce your intermediate CH2O negative MgBr plus. This is going to be your structure DD. Now, this structure, when undergo hydrolysis or H3O plus, the OMGBr will be replaced with OH. So this forms EE, which is a primary alcohol. Let's proceed to your marks. You have 1 mark for each correct structure. So AA 1 mark, BB 1 mark, while CC, DD, and EE gets 1 mark each. Continue with question number 4. Again, this is nucleophilic substitution. So this is going to be replacing Cl with NH2. So that is what ammonia is, H and NH2. So when NH2 replace, your structure is going to be CH3, CH2, CH2, NH2. This is your FF. Continue with question number 5. Again, this is nucleophilic substitution, but in this case, your Cl is going to be substituted with O negative together with the cyclobutane. So it's going to have CH2O and then the cyclobutane. This is your structure GG. Next, question number 6. Nucleophilic substitution is going to be with Cl and with the nucleophile here, Cn negative. So in place of Cl, you are going to have Cn. But be careful, the C is the one with the negative charge. So your attachment must be C and then N. So that will be your structure HH. So in terms of mark, each correct structure gets you 1 mark. So FF1, GG1, and HH1. So total for question 2A is 8 marks. Let's proceed to question number 2B. Give the structures of JJ2QQ and also reagent 122 in the reaction scheme below. So in this type of question, I have taken out each individual reaction so that we can see much easier. So let's start with JJ first. So when you have your haloalkane with benzene in AlCl3, this is actually from your chapter benzene. So what is this reaction? This is called Friedel-Crafts alkylation. Okay, I repeat, this is Friedel-Crafts alkylation. So Friedel-Crafts alkylation, what you are going to do is you are going to attach this whole alkyl group to your benzene. So it will substitute 1 H from your benzene and substitute with this carbon. So your JJ product is this structure. Okay, so in this case, the H that has been substituted is from here. So this type of reaction is electrophilic aromatic substitution, but the name is Friedel-Crafts alkylation. So this is your structure JJ, and 1 structure correct gives you 1 mark. Proceed to next part of the reaction scheme, KK. So when the structure with alkyl group attached to the benzene undergoes KMNO4H plus heat. So this is oxidation reaction. So as long as you have your benzylic carbon here, and this benzylic carbon has at least 1 benzylic hydrogen, yes, oxidation can happen. So this benzylic carbon undergoes oxidation to produce benzoic acid. Okay, only the benzylic carbon become the benzoic acid. So correct structure of KK gets you 1 mark. Next, we proceed to LL. So when chloroalkane undergoes reaction with KOH ethanol reflux, this is reaction of dehydrohalogenation, or the type of reaction is elimination. So what is it that you eliminate? You will eliminate one halogen and then the neighboring hydrogen, but this alpha carbon has two neighbor on the right and neighbor at the bottom here. So because the question says LL is major product, we have to follow elimination follows Say-Zef rule. So Say-Zef rule states that we have to form the double bond that has most substituted. So in this case, this will be the chosen carbon to be elimination product. So LL, your double bond should be here. So this correct structure gets you 1 mark. Proceed to question MM. So when haloalkane reacts with Mg in dry ether, this forms MM, and NM is your Grignard reagent. So Grignard reagent, basically, in place of Cl, you will have MgCl. The next reactions all are following through from Grignard reagent. So the first one, when the Grignard reacts with H3O plus or hydrolysis, it will form an alkane. So NN is the structure, alkane. So this correct structure is 1 mark. Next, when the Grignard reagent reacts with CH2O and followed by H3O plus, so this is actually methanol followed by hydrolysis. So when you react Grignard with methanol, you will produce a primary alcohol. So that is what OO is. So this is your structure OO, primary alcohol, and this gives you 1 mark. Next structure, when Grignard reagent reacts with an aldehyde, you can see here, followed by hydrolysis. So aldehyde with Grignard will produce a secondary alcohol. So this will be your structure PP, and then this correct structure gives you 1 mark. Proceed, the same Grignard reagent when reacted with, now this one is ketone, followed by hydrolysis, it will produce a tertiary alcohol. So this will be your structure of alcohol QQ, and this structure gives you 1 mark. And then last but not least, when your Grignard reagent, so this was your MM, reacts with something, reagent 1, it produces NH2. So this is nucleophilic substitution of your Cl substitute with NH2. So the reagent is excess NH3 in the presence of ethanol followed by heat. And this correct reagent gives you 1 mark. And lastly, when the Grignard reagent reacts with reagent number 2, it produces a carboxylic acid. So in place of the Cl, now it becomes COOH. So reagent 2 has two parts. One is carbon dioxide, followed by number 2, hydrolysis. So this both correct reagent gives you 1 mark. Next, we proceed to question number 3. You have compound RR reacts with bromine under sunlight to give tertiary haloalkane. So first, bromine under sunlight, this is actually free radical substitution. So we know that RR should be an alkane. Okay, only alkane undergoes free radical substitution. Next, it gives a haloalkane SS, but remember it should be a tertiary haloalkane. Hydrolysis of the haloalkane with sodium hydroxide produce alcohol TT. Now, because your haloalkane is tertiary, therefore your alcohol also should be tertiary alcohol. So they should be nucleophilic substitution of haloalkane with the alcohol. Okay, next, when the same haloalkane reacts with magnesium in dry ether, you have alkyl magnesium bromide, UU. So UU should be a Grignard reagent. And then reaction of UU with carbon dioxide followed by hydrolysis yields a carboxylic acid. So this has been told here. So draw the structure of RR, SS, TT, UU, and VV. So what we can do is we can produce our RR first, because RR is an alkane that is able to give a tertiary haloalkane. So in terms of C5H12, there is not much option for alkane RR to form tertiary haloalkane. So RR is only this structure. Okay, so where is the tertiary carbon? It should be here. Okay, so this is your tertiary carbon. So when RR undergoes free radical substitution with bromine, the alpha carbon here will be substituted, or the H from the alpha carbon is substituted with Br. So this is your structure SS. Now after that, SS becomes alcohol. So the same alpha carbons now have OH. So this is your structure TT. And then when SS reacts with magnesium dry ether, it produces Grignard reagent. So in place of Br, it now becomes MgBr. So this is your structure, UU. And then lastly, when this Grignard reagent reacts with carbon dioxide followed by hydrolysis, in place of MgBr, you have COOH. So this is your structure, VV. So you can see here all the reactions is happening on the same alpha carbon. H undergoes free radical substitution to become Br. So this is on the same alpha carbon. And then the Br substituted with OH. So this is still the same alpha carbon. And your Grignard reagent is formed from this alpha carbon. And then your COOH is added to the same alpha carbon. Right, so each correct structure gives you 1 mark. Moving on to question number 4, you are given the first step of reaction mechanism between 2-chloro-2-methylbutane and aqueous NaOH. So this is only the first step. So question A suggests the second step of the reaction mechanism. So first you need to identify what is the type of reaction here when you are forming a carbocation. So this should be SN1. I repeat, when you are forming carbocation, this is mechanism of SN1. So the second step of SN1 mechanism should be the attack of the nucleophile to the positive carbocation. So your nucleophile of NaOH is OH minus. So the OH minus attack the carbocation, and this reaction should be fast. And then the place of C positive will be added with OH. So this is your second step of the SN1 mechanism. So in terms of mark, the attack and the correct nucleophile OH gets you 1 mark, and the final product gets you another 1 mark. Proceed to question number 4b. You need to explain why is OH minus not involved in the first step of the reaction mechanism. So this you need to look at your starting chloroalkane. So 2-chloro-2-methylbutane, if you look carefully, it has 3 alkyl groups surrounding the alpha carbon. So the 3 alkyl groups, we call them as electron donating groups, or EDG. But what does EDG do? EDG reduce the partially positive charge on the carbon of the carbon Cl bond. Or in other words, reduce the partially positive charge on the alpha carbon. So what happens if your alpha carbon has less partial positive charge? The attack by the nucleophile is not favored, or OH minus does not attack the reduced carbon alpha from the first step. Alright, so in terms of marks, this explanation, both mentioning of the electron donating groups and reduced partial positive charge gets you 1 mark. And what happened? OH minus attack is not favored, gets you the other 1 mark. Let's proceed to question C. Name the reaction mechanism shown. So I have told you that this is SN1, but SN1 is not a full name. So full name is unimolecular nucleophilic substitution. So remember, you have to give the full name. Not enough if you just mention SN1. And this correct name gives you 1 mark. And then lastly, write the rate equation for the reaction between the haloalkane and the aqueous sodium hydroxide. So because this is SN1, the rate of reaction is only depending on the first step. So the first step, you only have the 2-chloro-2-methylbutane. So rate equals to K, concentration of 2-chloro-2-methylbutane. Next, we proceed to the last question of these 0 to hero haloalkanes. 1-bromo 2-methyl propane treated with dilute aqueous sodium hydroxide to form 2-methyl 1-propanol using SN2 mechanism. Show this mechanism and identify the rate determining step. So what you need to know about SN2 mechanism is that both the attack of the nucleophile and the leaving of the halogen happens at the same time. So when you happen at the same time, you need to show the 1-bromo 2-methyl propane in three-dimensional representation. So make sure you draw this in the correct 3D representation. So the nucleophile from sodium hydroxide is OH minus. So OH minus needs to attack from the back side. I repeat, OH minus needs to attack from the back side. So this is where your nucleophile attack, and at the same time Br will start to leave the alpha carbon. So the first arrow should be labeled as slow and rate determining step. Next, you will form your intermediate first, which is a transition state. So you need to draw the bond between carbon and the OH is starting to form, while the bond between carbon and Br is starting to break. So both of them will have partially negative charge on top of O and on top of Br. So this is transition state. Also remember to put the big bracket outside of the transition state. After you form this transition state, you will have a fast reaction. During the fast reaction, the Br will finally leave, but the OH will finally form the new bond. So you will have another 3D representation, but it will be inverted. So instead of Br facing right, now you have OH but facing left. So this is what it meant by inverted 3D representation. And don't forget to put your leaving group Br minus as your side product. So how do you get the marks? In the first step, you get 1 mark for both arrows, transition state 1 mark, and your final product 1 mark. And you label the correct rate determining step, you get the last 1 mark. Alright, so that will be the end of my 0 to hero chapter 7 haloalkanes discussion. Thank you very much.